Good morning, everyone. My name is Ivo Galic, and I'm a solution architect at Google Cloud. In today's session, we're going to talk about time series analytics and cutting-edge technologies in the streaming ecosystem. A time series is simply a series of data points ordered in time. In a time series, time is often an independent variable, and ability to predict or describe some properties of a series is a challenge for many businesses. Time series properties can vary between seasonalities, stationary properties, correlations, anomalies, etc. Time series visualizations and analytics are crucial for understanding your data. The ability to see your data and spot trends track change over time to generate forecasts is essential for many businesses. Likely for you with InfluxDB, time series data can be queried and graphed in dashboards spanning different types of visualizations, including line graphs, gauges, tables, and more. Time series data provides significant value to organizations because it enables them to analyze important real-time and historical metrics. Data is valuable only if it's easy to access. That's where being able to build dashboards that run repetitive analytical queries become a force multiplier for organizations looking to expose their data across the team. Biggest roadblock for most businesses is to truly utilize the power of AI analytics today is unstructured, incomplete, and scattered data. Most of the industries have some streaming data that's tabular in some sort of natures. Example of those data can be IoT sensor readings for manufacturing purposes, or trades or transactional data for financial or banking institutions. Healthcare monitoring metrics if you're a hospital or similar healthcare provider. During the process of data collection, streams of data will be emitted from sources that can generate the data in irregular intervals. Depending on your relativistic time observation preference, data and metrics can be emitted and stored in irregular intervals in the real-time or gap field. This is one of the main problems for consistency of predictions for feature extraction process when building streaming AI systems. As you know, prediction is a very difficult task, especially if it's about the future. Nonetheless, a team at Google Cloud and InfluxData have created a framework that can get you going in a matter of minutes. And we're going to discuss this today. If we assume that if you're watching this, you want to build something that can generate feature describing a fraction of series in a consistent way so you can replicate it for some kind of machine learning. Easiest way to do that is to use some existing framework and not to reinvent the wheel. In our series today, we'll be presenting cutting-edge open source framework based on Google service Dataflow created by Google Cloud team. David Sabatudinter, who is Google Cloud streaming analytics lead, will give us more details about Dataflow time series framework and expected functionality of a larger Beam ecosystem. Apache Beam is an open source, unified model and set of SDKs for defining and executing data processing. After that, we will boot InfluxDB on GCP and start a job that will get live Bitcoin price feed from a cryptocurrency exchange, Kraken, and we will visualize aggregate metrics like minimum and maximum for a price given time interval streaming into InfluxDB. Please leave your comments and questions below and we will try to answer them as soon as possible. All links to repositories and artifacts will be included at the end of the video and below in the comment section. And now David will give us an overview of Dataflow time series framework. Thank you very much.
So, first thing first, we're going to create an InfluxDB InfluxDB instance. We can easily deploy. We should go to the GCP and look for InfluxDB, find it there, Google click to deploy, and we just click on launch. We can disable and we can choose the zone, and we can disable HTTPS, and we can allow TCP to connect from the internet, because this is just a demo. Don't use this kind of settings in normal and we click deploy. Since this is gonna take a while to deploy, maybe 2-3 minutes, we can start looking at the code. So in this code, I'm going to show you classes I've used so far, and basically what I did is I cloned the repository that's currently on GitHub that David presented earlier, and that's linked in a description below, and I created a new adapter in it called Dataflow, and then after that I created 2 classes that are taking that are opening sockets towards Kraken crypto exchange, and they're sending trades, as you can see here, downstream as a trade load objects. And trade load objects are basically objects that contain price, volume, the delta between when was the trade issued from the exchange and how long it took actually to arrive to our system. And then the second class contains mostly checkpoints, output coders, readers, and watermarking logic. Now, if you're using IntelliJ, I recommend just adding all the classes into Gradle and defining a class, a start bootstrap class here. As you can see, exchange demo start. Now, if you run this task, unleash crypto for real, it'll start this class over here. And first thing first, you'll extract some pipeline factory options from arguments, and you'll set some default values in this scenario. And you can see options have some app names, duration for type 1 computation in seconds, for type 2 computation seconds, and sequence length in seconds, and TTL duration, and so on. So the first thing first, we're going to create the unbounded source, as you can see here. Let me close this for ease of use. And then in the second one, we will create a converter that will convert this raw signal, and it should go into our TFX engine. So converter code is here, and you can see we are adding this, we are processing the element and taking it from the context, and you see here the time series data is getting this key, and the data is double value from here with timestamp that we decided it can be timestamp when we saw the trade, or timestamp when the exchange issued the trade. And now we define 3 different outputs, as you can see here, that will be processed. So for every single of these metrics, both price, volume, and delta, we will create all these metrics around them, which you'll see later on. Okay, so looking at this, furthermore, here you'll define the computations that you want to use for this. Now, if you go and press Command B, you'll see all the computations out there, like simple moving average or exponential moving average, or type 2 computations like RSI or similar. Now, we mentioned earlier the need for gap filling. You know, what if there is no data and you want to have a consistent data? So we're doing it with perfect rectangles class, which will do the Holden principle gap filling. And then here we'll have some additional settings and printing going towards the end. You'll see multiple settings, and prun will run the pipeline. After we run the pipeline should, okay, I didn't expect that to happen, so I'll just go to the terminal and I'll unleash crypto for real, and I'll provide some output locations. Now we expect to have now multiple metrics here. And if we navigate to inside of Influx database at this moment, and we connect with username and password, we should be able to see, after first we should check what databases are out there. So but I know for sure, let's check that out. Show databases. You see internal test, and we'll just use test for this purpose. And then I will show measurements. And as you can see, we have defined these measurements earlier on. So I can go ahead and I'm going to select all measurements from price. As you can see, the way how we've written it, we just added the type of the value, but if I expand it, it should contain, as you can see, all the metrics that are out there. You see apps moving average, gain, loss, and so on, exponential moving average, and so on. So this is streaming in real time, and we are seeing data in real time in InfluxDB. The code should be available as soon as we get permission for a release of the code. Thank you very much, and you can find more links and information about pieces of this code in the comments and